Welcome to this presentation of a Southland Hub Future Farming Systems project. I'm Owen Gibson, a researcher from Foundation for Arable Research, and join me as I take you through this project so far. So about the project, we have a 2 hectare paddock at Knapdale that is split in 2 sides. One is a best practice or conventional system, whereas the other side is a future farming system. We have a grower group to plan all rotations and operations within both blocks, and it's initially developed for a 3-year period, but hopefully we can extend this if it's working as we think it should. All plans, operations and changes to plans are recorded, and we're assessing the financial costs between both blocks, the environmental effects of what we're doing on each system, and the impact that has on the soil and crop structure. So the trial location is located next to the Knapdale School. We've split the paddock up, as you can see in the picture. The future block is essentially 1.2 hectares, and the conventional block is 0.9 of hectare. So where did we start? So this trial started with going into green feed oats, as you can see in the picture, which we then split in 2, with half being grazed by store lambs prior to putting in spring barley, whereas the future side on the right, we retained the oat biomass and we direct drilled into their system. Before the sheep went in, we took soil samples. Now this is a composite across the entire paddock, but we had just under 20 kgs of mineral N in 0 to 30, and just under 80 kgs and 30 to 60. One of the issues we've seen with this paddock so far is we have a very low pH. We've got down from 5.7 to 5.9, and also our Olsen P levels from 15 to 21 is something where we're trying to adjust. Potassium is low with our quick test between 2 to 4. And what we're doing as the project goes forward, we set up grid soil sample points, which we're going to sample from each year to see how we're coming along with changing these some of these low results. So the paddock went into spring barley in mid-November. Obviously, Southland had quite a wet spring, which made it difficult getting the barley in. So we're late planting in November. On the conventional side, we cultivated, which consisted of ploughing, power harrowing and levelling, which we drilled with a Horsch Avatar drill. And on the future side block, we direct drilled into the oat biomass with a Novag direct drill. This is how it looked at drilling. As you can see on the left, the conventional side has got quite a fine, even seed bed. Whereas on the right, you can see the amount of biomass that we're direct drilling into with the Novag drill. This is what the 2 sites looked at mid-tillarine or late tillarine. It's quite a difference between the 2. The conventional is looking quite nice and uniform, and on the future side, we're already starting to see a bit of variability. Particularly, you see quite a few wheel marks going across the paddock. And that continued to show up as the project went forward. This is what it looked like early March. We're getting close to harvest. The conventional side's looking nice and uniform, whereas the future side has continued to struggle. There's a lot of green secondary tillarine. There's quite a lot of weeds around the outside of the paddock where it's bare. We haven't had good establishment, but yeah, quite a big difference between the 2 sides. So what were the difference in the inputs? We talked about the cultivation on the conventional side. By keeping the oat biomass on the future side required us to apply 2 rounds of slug baits. We used Metarex to control slugs. They were very damaging at early establishment, and they did cause quite a bit of thinning within the crop. The most notable difference between the two sides is the lack of fungicide applied to the future side. We had low disease pressure early on when we were monitoring the paddock. So the decision was made to see if we could get away without applying any fungicide on the future system. What we did apply at drilling, we put diversity seed treatment down, or applied diversity seed treatment, treated seed. We used silhouette barley between the two blocks. And also both sides had the same base fertilizer applied to them. So this is what it looked like from a year. And obviously you can see a huge difference straight away. The amount of wheel tracks going across the future side on the left was caused by rolling the paddock early. The crop never recovered from that operation. We use variable rate nitrogen application using an N sensor, a tractor mounted N sensor across the block, and you can see the spread map on the bottom right. So observations in the barley so far, we've not harvested this paddock yet, we're just about to. But what we did see is plant counts at early establishment were actually not too different between the two systems of 217 in the future side and 240 in the conventional. But come late crop maturity, which you can see the photos, the drone photo, and the other ones taken at a more mature crop, you can see we have pretty much a third less heads in the future side than we do the conventional side. The breakdown between primary and secondary tillers is not a lot of difference. However, these were taken from most of the middle of the paddock where it was stronger in the future side. If we're taking these out around the headlands, it would be a big difference. For biomass, there was a 1.5 tonne difference in crop biomass between the future side and the conventional. So obviously we're going to see quite an impact on yield between the two blocks. However, what I do want to state is this project's not looking at one individual crop. So as we go forward, we may start seeing benefits from this direct drilling moving forward compared to the conventional. But that's something we just have to wait and see. So we have a site in Chertsey where we're running a similar trial. We've been doing this for 2 seasons now. And I thought I'd share some of the technology in action and some of the results we found from our Chertsey site. So all pesticides have been applied by drone on our future block in our autumn wheat crop, as you can see here. And all nutrient applications have been applied by drone as well. So this has caused us some issues. This hasn't been plain sailing. You can see in the photo, the future side is on the right. You can see the stripping through the paddock. That was by uneven nutrient application. When we applied the first round of urea by the drone, we put out spread trays to see what the spread pattern was. You see 20 sites along the x-axis, which were placed 2 meters apart, and there's quite a lot of variability going across. And that's what's caused the stripping, as we see in the drone image on the left, as well as the previous photo. We put out water-sensitive paper to see how the spread or the spray pattern was across the site. Also, this was done in 2 meter spacings. It's not too bad, but there are some papers there that are quite worrying with the limited amount of chemical that's been applied to them. This was done quite late, so I'd say we are getting a little bit of shading from the crop in some points, but it's interesting to see what it's doing for us. So what are the main observations we're seeing from the Chertsey site so far? We planted in a processed pea crop for tallies in the first season. We saw an extra 300 kgs of biomass in the conventional than the future block, and the conventional block yielded 1 tonne greater than the future block. However, this was at a higher maturity because there were slightly different maturities come harvest time. So it actually ended up being put into a lower pay bracket in the conventional compared to the future, which adjusted our gross margins. Fewer operations in the pea crop. We direct drilled into a standing oak crop, similar to what we did at the Southland block. And this allowed us to obviously remove cultivation activity, but also we didn't apply any herbicide to the future side block, and we used the oak biomass, which was between 4 to 6 tonnes a hectare of biomass, to create a thatch and reduce our weed burden. And it worked really well in this trial over that season. Soil moisture, we had 5 mils difference in soil moisture on the future block. We thought this would only show up just after our cultivation and then it would level out over the season. However, this 5 mils retained across the entire growing period of that pea crop. It didn't continue into the next crops, what's with buckwheat and autumn wheat, but it was interesting to see how much of a difference it did make by retaining the oak biomass and also direct drilling in the future side. Increased soil mineral nitrogen. So coming out of the peas, we planted buckwheat, and when we harvested the buckwheat, we took soil samples between the two systems, and we had 80 kgs more nitrogen in the future block than we did conventional. The difference between them, we retained the pea vines in the future block post-harvest and direct drilled the buckwheat, whereas we baled and sold the vines in the conventional side before direct drilling. We put trichoderma in at each crop timing, apart from the buckwheat. So the peas had platform trichoderma seed treatment applied, and also when we put in the autumn wheat. We had increased biomass in the buckwheat on the future side, but this did not relate to an increase in seed yield. They both yielded roughly around 3.3 tonnes a hectare. But we did see that extra nitrogen coming out of the buckwheat in the future side. Decreased pesticide applications in the wheat crop. For the wheat crop, we planted a tri-mixture in the future side, which consisted of Graham, Voltron, and SY Defiant, compared to a monocrop in the conventional side of Graham alone. Both sides were planted at 90 kgs a hectare. But in the future side, we ended up only applying one fungicide application at a T2 timing compared to the full program of a free spray program at T1, T2, and T3 in the conventional side. However, at our Chertsey side, we had very low disease pressure this season, so we managed to get away with that, which we did not at the Knapdale site in our spring barley. Increasing carbon stocks, so we're monitoring our organic matter, our carbon. We've got 1% higher organic matter in the future side compared to conventional. However, this is only in the top 0 to 15 centimetres. If you go through the whole profile down to 50 centimetres, they are the same. But having that extra percent of organic matter in the 0 to 15 centimetres is an advantage because that's where our main root mass is. So it'll be interesting to see how that progresses over time. And also less greenhouse gas emissions in the future block compared to the conventional, which is primarily driven by reduced nitrogen inputs. So where to from here for the Southland hub system? So we're about to harvest the spring barley. Coming out of that, we're going to be going back into a oat cover crop for winter, and then into spring, the plan is to go into a maize crop. We're looking at ways or differences we can do in the maize crop, but hopefully it may look like the picture on the right here, which was a very good crop we had at our Chertsey site a few years ago. But I'm really excited to see where the project goes from here. I'd like to take the time to say a big thank you to everyone who's helped in this project, particularly the members on the steering group. Without their help and their giving up their time, this trial or this project would not be what it is. So Thank you very much. And I'd like to hear from people if I'm in the region, and any comments would be great. Thank you.